Hello ladies and gentlemen, welcome to the first video of Chapter 10, which is Section 10.1, Use Properties of Tangents. Chapter 10 is all about circles. We're going to be learning a lot of definitions and a lot of formulas and a lot of theorems, and then we're going to apply them. As normal, Section 1 is kind of the background on circles. So a whole bunch of objectives. The first one is we're going to identify parts of a circle, like the radius, the diameter, the center. Those are things that you should have talked about before. We are going to identify common tangents, those that are internal and external common tangents. We are going to determine if a segment is tangent to a circle, and then we're also going to find tangent and radius lengths using tangent properties. So as you can see from the objectives, all day today, or all video, we're learning about tangents. So first, let's do some background with some definitions. A circle is the set of all points in a plane equidistant from the same point. And that same point is called the center. Okay, so let's see what this looks like. So we have some point, a center, and then we have all the points that are the same distance from that point. So I have a point here that's some distance away. I'm going to put another point that's the same distance away, so equidistant. So maybe it's 5 units, 10 units, 15 units, whatever it is. And as you notice, if I find all these points that are the same distance from the center, they're all some units away, 5 units, 10 units, something, I end up forming a circle. So here's our circle. It's all the points that are the same distance from the center. And that distance is called the radius. So the radius is the distance from center to outside of circle. So in our example, this right here is the radius. Okay, next one is a chord. A chord is a segment with endpoints on the circle. So in this case, here is a chord. It has endpoints on the circle, and it's a segment. That's really important. It's not a line. It's a segment. It has a beginning and an end, both the beginning and the end being on the circle. A diameter is a chord passing through the center. Okay, so chord meaning that it's a segment with endpoints on the circle. So it's going to start and end on the circle, but it also is going to pass through the center. So here is a diameter. Okay, all of those you should really have known before. The secant and the tangent are going to be the ones that are different. So a secant is a line which intersects the circle twice in 2 places, whereas a tangent is a line that intersects the circle once. Okay, so in the circle we have, this would be a secant. Okay, so it's a line. It intersects in 2 points, once here, once here. And then a tangent would be a line that intersects the circle once. So it's going to like hug the side of the circle. This would be the point of intersection. So this is a tangent. One important property that you should remember from previous classes is that the radius is half the length of the diameter. So if the diameter is 10, the radius is going to be 5. So hopefully you remember that. The first example that we have is going to apply these definitions. So it says categorize each of the following as a radius, chord, diameter, secant, or tangent. So I'm going to do the first and second one with you, and you're going to do the next two. AC, so it's talking about this segment right here. It goes center to outside of circle, so this is called a radius. AB, so this right here, center to outside, so it crosses all the way through and goes through the center. So this one's a diameter. Pause the video and see if you can do the next two. Okay, DE is a line intersecting the circle once, so this is going to be called a tangent. And then AE is a line that intersects the circle twice, so this is going to be called a secant. Those should not have been very difficult, so hopefully you did well. Moving on, now we have example 2. We are asked to find a radius and a diameter of 2 different circles. I'm going to do the first circle with you, you're going to do the next one. So the radius of circle A, radius, remember, is center to outside. So here is going to be 1 radius. That's 3 units long. If the radius is 3, the diameter has to be 6 units long, because it's double. And if we check that, going from one side of the circle to the other, going through the center, is going to be 6 units. Now you answer the same 2 questions for circle B, please. We should have gotten 2 and 4. So hopefully we did. Before we move on to the next few examples, I want to talk a little bit about notation here. So this notation means circle with center B. So same thing, this means circle with center A. So if we were talking about this green circle, we would call it circle C. If we were talking about the black circle, we would call it circle D. It's always named by what point is at the center. So it's really, really important to remember, so please make sure you make a note of that. Okay, let's move on. Okay, next thing I want to talk about is intersecting coplanar circles. So coplanar just means that they are on the same plane. Okay, so if I have 2 circles, they could intersect 0 times, they could intersect 1 time, or they could intersect 2 times. Circles that do not intersect could look like this. They're just next to each other, they plain don't intersect. Or there could be one inside of another. Circles that intersect once could look like this, where they have 1 point of intersection here. Or, again, it could be one inside of the other, but with a point of intersection. And then circles that intersect twice, you've seen this before, hopefully. You probably used it in an English class, maybe. It's called a Venn diagram. So I have 2 points of intersection, one here and one here. Okay, the reason we need to know this is we're going to talk about something called common tangents. A common tangent is a line or segment tangent to 2 circles. Okay, so if I look at some of these previous examples, for 2 intersection points, for example, there's a common tangent right here. It's going to intersect once and intersect again. Okay, and then there's internal and external common tangents. So internal common tangent, it passes between the middle of the 2 circles. Whereas an external tangent stays on the outside. Of the 2 circles. I know that's a little confusing, so I just think we should look at an example to see what those look like exactly. So examples 3, 4, and 5, it says draw in the common tangents in the figures below. So for example number 3, I have this tangent right here I have this tangent right here. Remember, these are tangents because they intersect the circle once. They're common tangents because they're tangent to two different circles. These are both called external tangents, external common tangents. They stay outside of the two circles. Internal, on the other hand, would be this common tangent right here, and then this common tangent right here, because they pass in the middle of the two circles. So example 3 actually has 4 common tangents. I would like you to try examples 4 and 5 on your own, please. Draw in the common tangents, and then tell me if they're internal or external, please. Let's see how we did. For example 4, you should have come up with this external tangent and this external tangent. And, tricky, there's one more that goes right through the middle. And this one is the internal. Example 5 should have had one here, and they are both external. So hopefully those went well for you. If not, hopefully you see what mistake you made. Okay, next we have another theorem. And then we're going to do some examples. So it says a line is tangent to a circle if and only if it is perpendicular to a radius of the circle. So in the figure that we're given, we have this line M that is tangent at P. This P is actually called the point of tangency. So it's tangent at point P. We know it's tangent because it's perpendicular to a radius. So the way that we're going to see this a lot of times is we're going to be given a figure and it's going to say, is this line tangent? And we're going to have to see, is there a right angle? So let's look at what that looks like. Okay, so example number 6 is what I just explained. It says, in the diagram, PT is a radius of circle P. Is ST tangent to circle P? By the previous theorem, ST will be tangent if this is a right angle. So I need to determine, is that going to be a right angle? Well, I need to think. I formed a right triangle, possibly, or I really need to determine if it's a right triangle. How can I do that? Well, I can use the Pythagorean theorem. So I need to know, is 35 squared add 12 squared? Is that going to be equal to 37 squared? Okay, so on the left side, I get 1,369. On the right side, I get 1,369. They are equal. So we're going to say, yes, ST is tangent. Tangent because it forms a right triangle. If it didn't form a right triangle, like my left side and my right side were not equal, then it would not be tangent. Going off of this example is example number 7. It says in the diagram, B is a point of tangency. Find the radius of circle C. So this time we are told definitively that AB is a radius, which means that, or AB is a tangent, which means that this is a right angle. Definitively, that has to be a right angle. But now I'm asked to find the radius. Again, right triangle, so I'm going to use Pythagorean theorem. My two legs are 80 and r, so I have 80 squared plus r squared equals. This is the part that's tricky. The entire hypotenuse is going to be 50 plus r, and then I want to square it. Left side, simplify like normal. 80 squared is going to be 6,400. R squared is going to be r squared. This is the one that's more difficult. I have to remember that when I square something, it means to multiply by itself. So I have 50 plus r multiplied by 50 plus r. Okay, so I like the box. Some of you like to use that term that's similar to aluminum that I'm not going to use. But if you want to do it that way, that's fine, or draw in arcs, that's fine. 50 multiplied by 50 is 2,500, and then I get 50r, and then r squared. So substituting that back in, I have r squared plus 100r plus 2,500. Initially, this looks like it's going to be pretty difficult, but what we should notice is r squared and r squareds are going to cancel. That will always be the case. R squared should always cancel itself out. Then if I subtract 2,500 from both sides, I get 3,900 equals 100r. If I divide by 100, I get r equals 39 feet. Okay, next example I would like you to try on your own. It says in the diagram, B is a point of tangency. Find the radius of circle C. Okay, this is very similar to example 7, just new numbers. So take a minute, do this one on your own, please, and come back when you have finished. Okay, you should have had enough time to try this one on your own. You should have gotten x to be 33. If you did not get that, you did something wrong. You need to go back and fix it. When you come to class tomorrow, I'll be checking to see that you have all the work and the correct answer for this problem. Okay, let's move on. There's one more theorem. It says tangents from a common external point are congruent. So if we notice in the figure, we have two tangents. We have SR and ST. They come from a common external point. So all that means is they come from the same point S. That tells us they will be congruent. So in figure number 8, it says RS is tangent to circle C and RT is tangent. Find the value of x. Okay, so I have two tangents. They come from the same external point, which means they are going to be congruent. Okay, congruent, we need to kind of jog our memories a little bit. It means they're going to be equal. So I have 28 equals 3x plus 4. Subtract 4. I have 24 equals 3x, and x equals 8. Okay, and that was the last theorem for the video. We had a whole bunch of objectives, 4 objectives. The first one was to identify parts of circles. So we talked about secant and tangent and radius and chord. We identified common tangents, including internal and external tangents. So that's when you had two circles and you had to draw in the tangent that was tangent to both circles. We determined if a segment is tangent to a circle, so we used the Pythagorean theorem. And then we found tangent and radius links using tangent properties. So that would be like example 8 and then examples 6 and 7. That is the end of the video, of the required video. There's 2 more examples that you can do with me if you would like. My suggestion for you, if you would like to do these 2 problems, is pause the video right now and try the problems on your own. I'm going to give you the answers. If you got them right, awesome. If not, I'm going to go over the 2 problems. So pause the video right now and try these 2 problems on your own, please. Okay, let's see how we did. First example, you should have gotten x equals 16. Second one, you should have gotten x equals 5. I'm now going to go over both of those problems. So if you had any issues, you will see how to do them. For the first one, you should have done Pythagorean theorem. So we get 63 squared plus x squared equals 49 plus x squared. Because remember, point of tangency means we have a right angle. Now we need to simplify this. I get 3,969 plus x squared equals. Here is where I personally make the box. (49) multiplied by 49 is 2,401. Then I get 49x, and x squared. Combining like terms, I have x squared, add 98x, add 2,401. Okay, I have x squared on both sides, so those are going to cancel, which again should always be the case. I'm going to subtract 2,401, and I get 1,568 equals 98x. Dividing by 98, I get x equals 16. If you made a tiny mistake, not a big deal. Hopefully you at least had the correct setup. For the second one, we have two tangents that come from the same external point, so they're going to be congruent. Congruent, I can set them equal. I get 4x plus 7 equals 7x minus 8. Adding 8 to both sides, I get 4x plus 15 equals 7x. If I subtract 4x, I get 15 equals 3x, and x equals 5. Okay, so hopefully we now see what mistakes we made, or we got a little bit of a clearer understanding of this section. When you come to class, we will be doing some more identifying. So which one's tangent, which one's a common tangent, which one's a secant. And then we're going to be using these tangent properties with the Pythagorean theorem. Please bring any questions you have to class tomorrow. Thank you.